Hi, ladies and gentlemen, Mr. Green here again, and we're zooming through this unit on system of equations. Really not so hard yet. I mean, I understand everything we're doing so far. Of course, Mr. Green, you're the teacher. Well, yeah, kind of, but it's really not that big, the big deal. What we're looking at is we're trying to combine equations together to see where that one point where they intersect, that one value that makes them both true at the same time. Remember? Okay? So the big idea with what we're going to be looking at today is not every equation does substitution work out to be the easiest way to do it. Yeah. Okay? So they have this technique that they call linear combination. That's where we're going to try to combine things together. Okay? And I want you to remember, you can either have no answers because you have parallel lines, an infinite number of answers because they're the same line, or just one answer because it's an intersection of two lines. So let's look at a couple of equations here. So I've got these two equations here. Now, you know what? I could start manipulating one of these and get it equal to either an x or a y and substitute it into the other one. But I notice, and I'm just making an observation, these two right here are opposite each other. I've got 2y and minus 2y. What would happen if I added these two equations to each other? Well, I'm adding the same thing to both sides of the equation because they're both equations, right? So if I'm adding this to the first one and adding 10 to the other side of it, I'm adding the same amount to both sides of the equation, so it's still a balanced equation. So let's just try to add them. And I'm just going to do it just like it was an adding here. 4x plus 3x is 7x. 2y minus 2y is 0. So I'm not even going to write that down. 0 equals 9 plus 10 is 19. Look at this. Now I've only got one value here. So I could say that x is equal to 19 over 7. What did I do? I divided by 7. I skipped that step. But you can see how I got a value for x real quickly, didn't I? This is called linear combination. Sometimes just by observing that they're the same, I can figure out that I could add them down that way. Let's stick this value for x into one of these equations up here. 4x plus 2y equals 9. So that's 4 times 19 over 7 plus 2y equals 9. So 4 times 19, that's here, 76. Yeah, 76 over 7 plus 2y equals 9. I'm going to subtract the 76 over 7 from both sides of the equation. And what am I going to get? I'm going to get 2y is equal to put this over 7, 9 times 7 is 63. 63 over 7 minus 76 over 7. And the reason I did that was to get, so I could do the fractions. And all I did there was say, well, that's 9 over 1. So if I multiply that by 7 and that one times 7, I get 63 over 7. That's all I did there. Okay? So 63 minus 76 is a minus 13 over 7 equals to y. So y is going to be equal to, because I'm going to divide by 2 or multiply times 1/2, negative 13 over 14. I have two values. I've got an x and a y value. I've got an x of 19 over 7. I've got a y value of negative 13 over 14. Yes, ugly little fractions, aren't they? But those ugly little fractions are why we had to do linear combination. If we tried to do this with substitution, it would have been a whole lot messier. Trust me. Okay? That's why these worked out so easily here. So let's see, Kate, we'll do another one. See if you can see what I'm talking about. Looking at this equation right here, well, I've got y equals here. Sometimes linear combinations are just as easy as they sound. If I subtract this one, this one from the one above it, y minus y is 0 is equal to 3 minus 1 is 2x plus 4. you know what? I can subtract the 4 from both sides, divide by 2, and I'm going to get x is equal to a negative 2. That means y is equal to a negative 6. Substitution? No. It was linear combination that I used right there. Look at this one. I'm going to subtract this from both sides. Geez, Mr. Green. Subtract that should have been negative 4. That should have been a positive 2. That would have been a positive 6. 2, 6. Sorry. I'll try to go a little slower this time. I'm going to subtract this. That means I'm going to multiply this times negative 1 and this one times negative 1 so that when I add them, I get them correct. So I'm going to have y is equal to 3x plus 2. Y minus y equals minus 5x plus 10. Now when I add these down, I get 0 here is equal to minus 2x and 12. Okay? So I can add the 2x to the other side is equal to 12. X is equal to 6. Ta-da! Come back to this first equation. 3 times 6. Well, that's 12. 3 times 6 is 12. Plus 2. That's 14. So y is equal to 14. My point in this situation is 6 comma 14. Cool. Let's try another one here. And here I've got, oh my. Wow. This one looks a little bit more complicated. See, I can't just add them and get rid of one of the variables, will I? Because if I subtract this one down here, I wind up getting an x still. If I subtract this one the other way, I wind up getting a y. So no matter what I do there, I'm going to wind up with both the variables. It's not helpful. You know what? I'm going to save this one for next time. And it'll just make a little bit of difference. So we'll just take this a little step at a time. Okay? Well, I'll talk to you next time then.